Hello friends, in this session we are going to see the factorials part of the number system. These are again one type of question that if you know how to solve this question, you can easily solve. But if you don't know, you don't have exact idea, then it is difficult to solve those in the given time. Questions are going to be very easy. They are going to be very typical questions. So let us understand what kind of questions we are first talking about. The questions is, how many trailing zeros a number will have? A number could be 50 factorial, number could be 24 factorial, and any number like this. How many trailing zeros? Now, what do you mean by trailing zeros? If I say write a number 210100. So how many trailing zeros this number have is 2. Trailing zeros means only the zeros, those are from the right hand, on the rightmost side. So there are 2 trailing zeros. These 2 are called as the trailing zeros. This is not counted. Okay, so 50 factorial is going to be a huge number. 50 into 49 into 48 up to 3, 2, 1. So it is definitely going to be a huge number. So how many trailing zeros this number will have? This is what we are going to learn in this topic. But let us start with the basic first. If I ask you, how many trailing zeros will be there in the number 2 into 2 into 2? Now 2 into 2 into 2 is 8. 8 doesn't have any trailing zeros. So 0 trailing zeros. If I multiply here with 3, 8 into 3 is 24. It again doesn't have any trailing zeros. If I again multiply it with 3, so 24 into 3, 72, again doesn't have any trailing zeros. But if I multiply here, let's say again with 5. Now, what the numbers, all the numbers that I am writing are the prime numbers. So I am writing a prime factorized form of a number. What do you mean by prime factorized form? For that, please refer the factors video, the video before this. So once we write 5 into this product, so 72 into 5, this number is going to be 360 and it will have 1 trailing zeros. So 1 trailing zero is created. Now, why that 1 trailing zero is being created? Because we multiplied 5. 360 is nothing but 36 into 10. It is a multiple of 10. That means we can say it has 1 10 into it. 36 into 1 of the 10. And this 110 is created by 1 5 and 1 2. 5 into 2 is 10. So because in our product we have 1 5 and it multiplied with one of the 2's. So this pair of 5 and 2, they got us 110, and that is why 1 0 is created. If I multiply this again with 5, that means that 360 into 5. So again, if multiply it with 5, it will become 360 into 5. That is 1800. So it will have now 2 trailing zeros. Why 2? Because now we have 2 pairs of 5 and 2. This one more 5 and one more 2. They will form another pair. If I multiply again it with 5, so this 5 and this 2 again will form one of the 10, and 1800 into 5, 9000. It will have now 3 trailing zeros because now we can form 3 pairs of 5 to 5 to 5. If I multiply again it with 5, so now it is going to be 9000 into 5, 45,000. It will still have only 3 zeros because now we don't have any 2 into it, only 1 5 into it. So for that 5, we don't have any 2, so there won't be any pair, and that's why there will be only 3 pairs and hence only 3 zeros. If I now multiply with 2, so one more pair can be formed. So 45,000 into 2 will now have 90,000, means 4 zeros because there will be 4 such pairs. So it's easily we can say in a product form like this, the number of pairs that we can form out of 2 and 5, those many tens will be there, and the number of tens will give us number of trailing zeros. Or in other words, out of 5s and 2, whoever will be in the critical case, the critical means lesser in number. So whoever will be in critical numbers or lesser in numbers, those will decide the trailing zeros, the number of trailing zeros. So if I say 2 raised to the power 3 into 5 raised to the power 2 into 3 raised to the power 5 into 7 raised to the power 2, how many trailing zeros this number will have? So all you have to think for is, there are 2 number of 5s, there are 3 number of 2s. the decision maker is going to be 5 here because 5 is in critical. The number of 5s are lesser. There are only 2 5s. So that's why there will be 2 trailing zeros. So I hope you understood it. So if a question is simply in form of product like this, the number of trailing zeros are decided by the critical, the number which is in the out of 2 and 5. Whoever is lesser in number will decide the number of trailing zeros. If I write another case, 2 raised to the power 3 into 5 raised to the power 5 into 3 raised to the power 2. So how many trailing zeros this will have? This time we have three number of 2s and 5 number of 5. So this time critical will be the 2s. We have only 3 number of 2s, and that's why there will be 3 trailing zeros, because only 3 pairs will be formed out of 2s and 5s, right? This is about the normal product form. What if it is the factorial? So if I say I write how many trailing zeros are in 4 factorial. So 4 factorial will have 1 into 2 into 3 into 4. There is no 5 here. We have 1 2 from here and 2 2s from here. So if you want to write the prime factorized form of this, so there will be 2 2 2 2 raised to the power 3 into 3. This is the prime factorized form of a number 4 factorial, and that is 24. So we don't have any 5 into it, only 3 number of 2s. So that's why there are 0 trailing zeros. Once we write 5 factorial, 5 factorial will be 1 into 2 into 3 into 4 into 5. Now, if you want to write the prime factorized form, it is going to be 2 into 2 into 2. That is 2 raised to the power 3 into 3 raised to the power 1 into 5 raised to the power 1. So now we have 3 number of 2s and 1 number of 5. So the critical will be 5. So that's why there will be 1 trailing zeros. 5 factorial is 120. That's why there will be 1 trailing zeros. So now you must be understanding this, that as long as the numbers is into factorial, always the critical is going to be the 5s, because every second number is going to provide us the 2's multiple. Every second number is a multiple of 2. So we can have 1 2 from here, 2 2s from here. If we add one more 6, 6 also will have 1 2 into it. So because every second number will have 2 into it, but every fifth number will have 5 into it. So number of 5s are always going to be lesser than number of 2s. Number of 2s will always be in abundance. Number of 5s will always be in critical. So that's why we just need to count now number of 5s as long as the question is about the factorial. So how to count the number of 5s? That is our question now. So if I write a number, say 12 factorial. So how many number of 5s are there in 12 factorial? So if 12 factorial is there, you can manually also see 12 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. So this 10 being 2 into 5, it will have one of the 5 from here. And this is 1 5. So there will be 2 5s. And that's why there will be 2 trailing zeros. As we discussed, in case of factorial, only number of 5s are going to decide the number of trailing zeros, because number of 2s will be always in abundance. But if a bigger number is there, let's say 30 factorial, 80 factorial, then we can't write everything and just say how many number of 5s are there. So there should be a proper process. Plus, the question might be about number of 3s as well. What is the 3's power in 5 factorial? That means how many 3s are there in 5 factorial, if this is a question. So then also you should have some method for you. So that's why we are discussing this method now. How to count number of any prime in a number factorial number. So if I want to count the number of 5s in 12 factorial, the process you are going to follow is, see, I'll tell you the process, why it is happening. So why we do this. If you understand it, very good. But even if you don't understand, even if you think that it is a little difficult to understand or tricky to understand, you can just go to the final result and you can always follow just the process that we follow. You don't have to then understand. But if you understand, it will be really good, because the process is very interesting. It will increase your interest towards the mathematics. See, again, I'll take the same number, that is 12 factorial. I want to count the number of 2s in 12 factorial. So 12 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11 into 12. So how many 2s are there if you want to count? 2 will have 1 2 into it because it's a single 2. 4 will have 2 2s into it because 4 is 2 into 2. 6 will have 1 2 into it because 6 is 2 into 3. 8 will have 3 2s into it because 8 is 2 into 2 into 2. 10 again will have only 1 2 into it because 10 is 5 into 2. And 12 will have 2 2s into it because 12 is 4 into 3. So 4 will have 2 2s. And that's why when you write the prime factorized form of this number, you write in the power of 2, there will be 1 plus 2, 3, 4, 5, 6, 7, 8, 9, 10. There will be total 10 number of 2s when you write the prime factorized form. There will be how many 3s? If you want to count the 3s, the 6 will have one of the 3. The 9 will have 2 3s. So 1 3 from here, 2 3s from here, and 1 3 from here. So total 3s are going to be 4 in number. How many 5s will be there? There is 1 5 here, and there is 1 5 into 10 because 10 is 2 into 5. So 1 5 here, 1 5 here. So there will be 2 number of 5s. How many 7s will be there? There is only 1 7. How many 11s will be there? There will be only 1 11. How many 13s will be there? We are only writing the prime numbers. We are writing the numbers in the power of prime numbers. Any number can be written in the power of prime numbers or prime factors. That is called as the prime factorized form. So we are writing the prime factorized form of this number. So there is no 13 into this product, and 13 onwards, no prime number will appear. That means this is the prime factorized form of this number. So if you calculate this, this is going to be equivalent to 12 factor. So if I ask you how many 2s are there in this, you can't always manually count. The process here is, see, 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11 into 12. This is the number 12 factor. We are going to count the number of 2s into it. We are going to go round wise. In the first round, when you see, there are total 12 numbers. And every second number has at least 1 2 into it. At least 1 2 into it. So if I want to divide this number by 2, I can say 1 2 will be cut from here. 1 2 will be cut from here. So 2 2s are 4. 2 3s are 6. 2 4s are 8. 2 5s are 10. 2 6s are 2. That means we could found 6 multiples of 2. So if I say every second student in the class is naughty, in a class of 12 students, how many naughty students are there? So how will you do that? You will divide 12 by 2 and you will say there will be 6 naughty students. So same thing we did here. In the first round, we knew every second number is a multiple of 2. And that's why we divided 12 with 2. And you found out there are total 6 multiples of. Now the remaining number, they don't have any 2 into it anyways. They are odd numbers. They don't have any 2 into it. So now our duty is to find how many 2s are there in the product 1, 2, 3, 4, 5, 6. The remaining numbers now, after cutting 2, 2, 2, 2s from all these even numbers, what remains is 1 into 2 into 3 into 4 into 5 into 6. So into those 1 into 2 into 3 into 4 into 5 into 6. How much ever number of 2s are there, we are going to add those 2 more. So 2 1s are 2, 2 2s are 4, 2 3s are 6. So in these 6 numbers, as you can see, there are 3 number of 2s, 3 multiples of 2s. Remaining numbers, they don't have any multiple of 2, so we are not going to consider this. Whatever remaining here is 1, 2, 3. So into that product, we are now going to count how many more 2s we can extract from it. So you need to divide it by 2. That means you need to see 3 by 2, how many 2s it has. Of course, you need to write only complete question because it has only one number of 2. So total number of 2s are, in the first round, we found out there are total 6 multiples of 2. In those 6 multiples, there will be more 3 multiples of 2. And in these 3 multiples, there will be one more multiple of 2. And hence there are 6 plus 3 plus 1. There are total 10 multiples of 2. And hence the power of 2 is 10. So if you understood this process, it's very good. But even if you didn't understand, you just have to do is take the 12 from the 12 factorial, divide it by 2. Whatever the complete quotient is, divide that by 2. Again, whatever the complete quotient is, divide that by 2. You have to keep doing this unless the quotient you get is lesser than 2. Now you can't divide 1 by 2. So you have to keep doing it till this point. And then you have to add all the respective quotients. 6 plus 3 plus 1. You have to add everything. And those many 2's will be there. Got this? So if you now have to find out how many 3's are there. So all you have to do is divide 12 by 3. 12 by 3 is 4. Then divide 4 by 3. That is 1. So there will be 4 plus 1. There should be 5 numbers. I think we missed one of the 3 here. 1, 2, 3, 4, and this 5. There are 5 numbers. This 3 we didn't count in the first go. So there are total 5 number of 3's, and that 5 is coming from. Okay, similarly, if you have to count the number of 5's, so you just have to divide 12 by 5. The complete quotient is 2. You can't divide further 2. That means there will be 2 number of 5's. And so on. So this is how you are going to count the number of odd factors in any number. But in case of trailing zeros, our duty is to find only the number of 5's. So if I ask you how many trailing zeros are there in 24 factorial, how many trailing zeros are there? So all you have to do is divide 24 by 5. The complete quotient will be 4. That's why there will be only 4 trailing zeros. Easy? Let's see some questions based on this. You have to find out the highest power of 2 in the following. Highest power of 2 means the number of 2's basically. So 10 factorial, you'll divide 10 by 2. The quotient is 5. You'll divide 5 by 2. The quotient is 2. So total number of 2's will be 5 plus 2, that is 7. In 23 factorial, divide 23 by 2, that is 11. Divide 11 by 2, that is 5. Divide 5 by 2, that is 2. Divide 2 by 2, that is 1. So 11 plus 5 plus 2 plus 1, that is 16 plus 3, 19. So there will be 19 power of 2. 50 factorial. 50 by 2, 25. 25 by 2 complete quotient is 12. 12 by 2 complete quotient is 6. 6 by 2 complete quotient is 3. 3 by 2 complete quotient is 1. Just add everything. 25 plus 12, 37. And 3, 40, 46. 46 number of 2's will be there in 50 factorial. 100 factorial. 100 factorial. 100 upon 2, that is 50. And then 50 onwards, we have this already, 46. So 46 plus this 50, the answer is going to be 96. So here, there are going to be 96 trailing zeros. 96 2's, or maximum power of 2 is 96. Find the highest power of 3 in the following. So you have to take the 10 divided by 3 and take the 3 divided by 3 and just add this. That is going to be 4. 4 number of 3's. 23 factorial. 23 by 3, that is 7. 7 by 3, that is 2. Just add this, that is 9. So there will be 9 highest power of 2. 50. 50 by 3 is 16. 16 by 3 is 5. 5 by 3 is 1. So 16 plus 5, 21 plus 1, 22 will be the highest power of 3. 100 factorial. 100 upon 3, 33. 33 upon 3, 11. 11 upon 3, that is 3. 3's are 9. 3 upon 3, that is 1. So add everything. 44 plus 4, 48. 48 number of 3's in the 100 factorial. Easy? Now find the highest power of 4 in the following. So 4 means you don't have to divide it by 4 because 4 is not the prime number. The method that we learned is only for the prime numbers. 4 is not the prime number. So you can't just divide 10 with 4 and all. No. 10 factorial basically is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. So if you write the 2's power in this number, as we already have solved, 1, 2, 3, 4, 5, 6, 7, and 8. So 2's power in the 10 factorial is going to be 8, right? So if you want 4's power, you need to write this in terms of 4's power. So 2 raised to power 8 means 2 raised to power 2 raised to the power 4. That means 4 raised to the power 4. So there are highest power of 4 is going to be 4 in 10 factor. You can't divide it by 4 because that is going to give you a wrong answer. There are not only 2 4s, there are 4 4s into 10 factorial because there are 8 2's. 8 2's are there. 2 2's will combine to form a 4. And that's why there will be 4 number of 4's. So for a composite number, you have to see how the number is formed. If 4 is 2 raised to power 2. So you need to check how many 2 raised to power 2's are there in this number. That means it is 2 raised to power 2's what power. This is how you are going to see it. Okay, let's see next one. 23 factorial. So 23 factorial is how many 2's? We have already solved that. You can just consider that number of 4's from it. 50 factorial, we know it had 46 number of 2's. We already calculated that 50 factorial will have 46 number of 2's. So you have to write it as 2's power 23. And that means 4 power 23. So it will have 23 number of 4's. And similarly, just divide it by 2. How much ever number of 2's are there, divide it by 2. Those many 4's will be. That will be the highest power of 4 into that. Find the highest power of 5 in the following number. So 10 factorial, 10 upon 5, that is 2. 5 is a prime number, so you have to do this. There will be 2. 23 by 5, there will be 4. 50 by 5, that is 10. 10 by 5, that is 2. So 10 plus 2, there will be 12 number of 5's. 100 factorial. 100 upon 5 is 20. 20 upon 5 is 4. So 20 plus 4, there will be 24 highest power of 5 in these numbers. Highest power of 6 in the following number. Now 6 is 2 into 3. So for 1 6, we require one of the 2 and one of the 3. That means we'll have to find the number of 2's and number of 3's. But number of 3's will be lesser in number, number of 2's will be in abundance. Because 2 is a smaller number, right? As we have seen in case of 2 and 5. 5's will be always critical, 2 will be always in abundance. Similarly, 2 and 3, 3's will be in critical, 2 will be in abundance. So you just have to count the number of 3's into the number. So 10 is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. So we have 2's power as 1, 2, 3, 4, 5, 6, 7, 8. 2's power as 8. And 3's power as 1, 2, 3, 4, 5. 3's power as, 3, 4. 1, 2, 3, 4. 3's power as 4. That means we have 4 number of 3's, but we have 8 number of 2's. So it's like 2 into 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 2. We have 8 number of 2's, but we have only 4 number of 3's. So how many 6 can be formed out of this? These 2 and these 3 will form 1 6. These 2 and these 3 will form 1 6. There will be 1 6 and there will be 1 6. No more 6 can be formed because number of 3's are over. Although there are 2 remaining, but there are no 3's. And that's why only 4 6 will be formed. So 6's power or 6's highest power is going to be 4. So you don't have to count the number of 2's. Only the number of 3's are going to decide the number of 6's. So in 50, we have already counted the number of 3's. That same will be the answer for number of 6's. And for 100 also, we have counted the number of 3's. Same will be answer for number of 6's. I hope you got this. Find the number of zeros. Number of zeros, who decides? Number of zeros means number of tens. So who decides number of tens? 10 is 2 into 5. So 2 will be in abundance, 5 will be critical. So number of fives decide number of tens. So you just have to count the number of fives. In 10 factorial, we know 10 by 5, there will be 2 zeros, 2 fives, so 2 trailing zeros. In 23 factorial, 23 divided by 5, the answer is 4. So number of fives are 4. So number of trailing zeros will also be 4. In 50 factorial, 50 upon 5 is 10. 10 upon 5 is 2. 10 plus 2 being 12. There will be 12 number of fives, hence 12 number of trailing zeros. And in 100, 100 by 5 is 20. 20 by 5 is 4. There will be total 24 number of fives, hence 24 trailing zeros. Easy? Okay, now this is a general question. It's an important question. Let's try to figure this out. Can you find value of n such that n factorial is divisible by 1 lakh but not by 10 lakh? That means 1 lakh means it has 5 zeros into it. That means it should have 5's power as 5. There should be 5 number of 5's in that factorial. But it should not have 6 number of 5's into that. It should not be divisible by 10 lakh means 10 lakh is this. That means 10 raised to the power 6, or we have 6 zeros. That means we require 6 number of 5's. So a number should not have 6 number of 5's. A number should have only 5 number of 5's. Any factorial number like this. Can you form a factorial number like this? So we can first manually go. If I want to count, say 100, say 50 factorial. Just randomly, 50 factorial has how many 5's? 50 factorial will have 50 upon 5, 10, 10 upon 5, only 12. There are 12 5's. We are looking only 5 and 6 number of 5's, so we'll have to decrease our number. So let's take an example of 30 factorial. 30 factorial will have 30 upon 5, 6 and 6 upon 5, that is 1. 7 number of 5's. So no. Again, we can lessen. Let's say 20 factorial. So 20 factorial will have 20 upon 5, 4 number of zeros. We want a number which will have 5 number of zeros or 5 5's. So let's go to the next multiple, 25 factorial. Now 25 factorial will have 25 upon 5, that is 5, and then 5 upon 5, that is 1. That means 6 number of trailing zeros or 6 number of 5's. So 25 factorial onwards will have 6 or more than 6 zeros. But 20 factorial to 24 factorial, because even if you consider 24 factorial, it will have 24 by 5. 4 number of zeros or 4 number of 5's. And as you go to 25 factorial, directly 2 more zeros will be increased. Directly 2 more zeros will be increased. So the number of 5's are going to be directly 6. So 4 number of 5's till 24 factorial and 25 factorial onwards, there will be directly 6 number of 5's. So we cannot have a number which will have 5 number of 5's. We cannot have a number in factorial which will have exactly 5 number of 5. It is not going to happen because after 24 factorial, 25 factorial will directly have 6 numbers. So we cannot have such a number which is divisible by this but not divisible by this. I hope you got this. Next, n square plus 1 is divisible by 3. So you can, first of all, you can manually also put some values of n and check if it is possible or not. You can put n's value as 1, 1 square plus 1, no. 2 square plus 1, 5, no. 3 square plus 1, no. So if in first 3 goes, it is not going to happen. It is not going to happen. But what is the scientific reason behind it? It goes to the remainder theorem. So we'll have to go for the remainder theorem for that. See, n square means n into n plus 1 divided by 3. What is the remainder we are talking here? What is the remainder? So n, when you divide by 3, can have the remainder as either 1 or 0 or 2. it cannot have a remainder of 3 or more than 3 because we are dividing it by 3. If a divisor is 3, the remainder cannot be more than 3. When you divide n by 3, the remainder could be either 0 or 1 or 2. It cannot be more than 2. So consider the first case, that is the remainder is 0. So if this remainder is 0, this remainder will also be 0. And the sign between is into. 0 into 0 is 0. And this remainder being 1. 0 plus 1. The final remainder is going to be 1. In that case, the final remainder is going to be 1. So that means it is not going to be divisible by 3 if such a case is there. Second case, the remainder could be either 1. So if n by 3 will have 1 as a remainder, this n by 3 will also have 1 as a remainder. 1 into 1, 1. And this will have 1 as a remainder and the sign between is plus. So 1 plus 1. The remainder in that case is going to be 2. So if there is a remainder, that means those kind of numbers also not divisible by 3. And last case, if this remainder is 2, that means this remainder is also 2. This individual remainder also 2. This individual remainder also 2. 2 into 2, 4. 4 plus 1, 5. And 5 means the remainder is going to be 2 again. Because 5 once you divide by 3, the remainder is going to be 2. This we are going to see in detail in the topic remainder theorem. But right now, just the important thing is you can put, because it is said divisible by 3. So even if you put any 3 consecutive number and if it's not happening, it is not going to happen ever. Just understand that part. So in these 3 cases, if it is not happening, it is not going to happen because once you divide a number by 3, we can have only 3 remainders out of 0, 1, and 2. And in all 3 cases, if it's not happening, that means it is not going to happen. So you cannot find the numbers. In this case also no. In this case also no. Can you find a number such that n has exactly 7 divisors? Divisors means factors. Can you find a number where n has exactly 7 factors? Yes. 2 raised to power 6 will have exactly 7 factors. You know how to find the number of factors? For that, you can refer the videos of number of factors for this. You can just take this 6 and increase it with 1. Those many number of factors will be there. So 2 raised to power 6, 3 raised to power 6, 5 raised to power 6. All these numbers will have exactly 7 divisors. I hope you got this. Okay, so this was about the factorials, number of trailing zeros, and the highest power of any prime or composite numbers in a given factorial. Thank you for watching this video. See you all in the next one. Bye-bye.